So we've got a bag of mass 6 kilograms is picked up with a force of 90 newtons. Given that the only downward force is due to gravity, calculate its upward acceleration. So a good thing to do to start this question would be draw a little model. So there's our bag. We've got a mass of 6 kilograms. Well, we want to draw forces on there. How do I figure out what force comes from 6 kilograms of mass? Well, we'd use F equals ma. Okay, so it's obvious what m is. That's just mass, so it's going to be 6. And then acceleration. Well, if it's acting vertically downwards, it's due to gravity, which we take as 9.8 meters per second squared. Meters per second squared, so that's an acceleration. So we could do 6 times 9.8, and then we could figure out what the force applied by gravity is. So we do 6 times 9.8, I'm doing it in my calculator here, and we get 58.8, and of course that would be newtons because we've done kilograms times meters per second squared and got a force. Okay, so there's the force going downwards, and that's the only one because it says given that the only downward force is due to gravity, so that's 58.8. What have we got going upwards? It's picked up with a force of 90 newtons. Okay. So now you've got two forces, they're opposite to each other. So to work out the resultant force, we can just do 90, take away 58.8, and what do we get? We would get 31.2 newtons. Okay. So there is our resultant force, but that's not what the question asks. It asks, calculate its upward acceleration. So again, using F equals ma, we would have 31.2 equals our mass, which is still 6, times by our acceleration. Okay, so we need to figure out what this a is here. This is a pretty simple linear equation, so we can just do 31.2 divided by 6, and that will give us our acceleration. So that will be 5.2, and its acceleration, so it will be meters per second squared. So a particle is being pulled by a piece of string with a force of 17.32 newtons, an angle of 30 degrees to the horizontal. Given that there is no friction applied by the surface and that the particle is accelerating horizontally at a rate of 3 meters per second squared, what is the mass of the particle and what is the reaction force? So first thing I would do here is draw a bit of a model. So we'll have this ball here, which is our particle, and we have a weight, which we don't know yet. We do want to work out its mass, so that will come from working out its weight. Then we have the plane, and we have a reaction force, which is R, which of course is perpendicular to the plane. And then we have one more force, which is going here with a magnitude of 17.32 newtons. And we know this angle here is 30 degrees. Okay, so there's our model. Let's consider horizontal forces first of all. Well, you can see straight away that the normal reaction and the weight don't do anything horizontally, so it's just some component of this 17.32 newtons that will act horizontally. So you can see we've got a right angle triangle, we know its angle, we know the hypotenuse, so we can work out the adjacent or we can work out the opposite. In this case, we want to work out the adjacent because that's the one that's going horizontal, so we'd do 17.32 times cos of 30. Stick that in your calculator, you get 15 newtons. Then, well, we can work out the mass now because we know the acceleration and we know the resultant force. Okay, because we know it's not moving up or down, so we know the resultant force is just moving completely horizontally. So we can take F equals ma and sub in what we know. Well, we know the resultant force is 15. We don't know the mass, but we do know the acceleration, so it's going to be 3m for mass. So what is m? 3 times m is 15, so m must be 5. And we're working in SI units, so this must be kilograms. SI units because this is meters per second squared, and this was in newtons. Okay, so we have the mass. We just need to figure out the reaction force. Okay, so we need to think about what forces are acting vertically. Well, we're going to take upwards as positive. Okay, and what have we got acting vertically upwards? We have the reaction force, which is R, and then we have some component of our string being pulled, so it's going to be 17.32 times sine 30 because you can see our right angle triangle here, the bit going vertically is the opposite, so sine 30. And then, because we know it's flat on the plane, it's not coming off the plane, it's not going through the plane, we know that's equal to the weight. Okay, so the problem is now we have two variables. We have the weight, we have the normal reaction. Luckily for us, the weight is easy to work out because the weight is going to be from mass times acceleration because of this again. So the resultant force, in this case, is a weight. So we're doing the mass, which was 5, times the acceleration, which is going to be due to gravity. So 5 times 9.8. If you work that out, you get 49, and it's a force, so newtons. Okay, so now we can rewrite this equation as R plus 17.32 sine 30 equals, well, W, which we've just said is 49. Okay, so now solving this, we're going to do 49 take away 17.32 sine 30 in our calculators, and that will give us R, which if we stick it in a calculator gives us 40.34 newtons. So that's the reaction force, or the normal reaction.